Hello and welcome. My name is Brian Chu. I'm a Microsoft technical trainer. I'm here to walk you through the AZ-800 Administering Windows Server Hybrid Core Infrastructure course. Let's get started. In this session, we'll focus on deploying and configuring Azure virtual machines in a hybrid environment. You'll learn how to plan, customize, and automate Windows Server IaaS virtual machines. We'll cover both on-prem and hybrid scenarios, so you'll see these concepts apply in different environments. Let's begin by understanding how to plan and deploy Windows Server IaaS virtual machines. This is a foundational skill for managing hybrid infrastructure, and it's essential for leveraging the flexibility and scalability of Azure. Azure virtual machines offer flexibility and control with two main tiers, Basic and Standard. Basic tier is ideal for non-production workloads and offers limited features and VM sizes. But Standard tier supports premium storage and higher performance, suitable for production workloads. For more details, check out the Microsoft Learn module on Azure Compute. Azure virtual machines are grouped into categories based on their intended use. Each VM series is identified by a letter and number, indicating its configuration family. General purposes: balanced CPU to memory ratio, great for testing, development, and small database or web servers. Confidential compute is designed to protect data and code integrity in the cloud. Compute optimized offers high CPU to memory ratio, ideal for compute-intensive workloads like web servers or batch processing. Memory optimized, high memory to CPU ratio, perfect for memory-intensive workloads like databases. Storage optimized, high-performance disk I/O, best for big data processing. GPU supports graphics processing, suitable for rendering, video editing, and deep learning. And high-performance compute, fastest CPUs, and optional high-throughput networking for demanding workloads. All Azure virtual machine sizes support standard storage, and many support premium storage. Premium storage delivers SSD-level performance, while standard storage is similar to traditional hard disk drives. Each VM has an operating system disk for the OS, and data disks with the number of depending on VM size, and a temporary disk for short-term storage. Understanding these disk types helps you plan your VM deployments effectively. There are several ways to deploy Azure virtual machines. From the Azure portal, it is wizard-driven, user-friendly interface. Azure PowerShell offers automation and flexibility. Azure CLI, it is similar to PowerShell, but command line based. Azure Resource Manager templates, they are best for large deployments and automation. And Windows Admin Center, custom settings and migration tools. Remember, Azure virtual machines use predefined sizes, so you select from available options rather than customizing every detail. Deployment templates allow you to provision multiple solutions with consistent design. Templates are idempotent, meaning you can run them multiple times without unwanted changes. They support VM extensions like DSC, Chef, or Puppet. You can define dependencies and control the provisioning sequence. When working with templates, consider which resources to deploy, their locations, API versions, dependencies, and property values. An Azure Resource Manager ARM template consists of several sections. Understanding this structure is key to creating effective templates. Bicep is a new language for deploying Azure resources using declarative syntax. It's easier and more concise than JSON. Bicep files are converted into ARM template JSON. It's an instructor as code solution for Azure. You'll use parameters, variables, resources, modules, and outputs to define your deployments. Learn more about Bicep in the Microsoft documentation. You can deploy VMs from our templates using several methods. You can use Azure PowerShell. You use the new AZ Resource Group Deployment commandlet. You can also use Azure CLI. Use AZ Group Deployment, create with template files or URIs. You can use the Azure portal. Use the custom deployment pane. You can also take advantage of Azure Quick Start Templates GitHub repository. From there, you can find easy-to-use templates. Last but definitely not least, you can use Visual Studio or Visual Studio Code. You can author and deploy templates from these IDEs. Next, we'll explore how to customize Windows Server IaaS virtual machine images. This is important for creating standardized, reusable VM configurations that meet your organization's needs. VM images are templates containing a generalized operating system and optional pre-configured software. You can find the images in the Azure Marketplace or build your own. Available images include Linux, Windows Server, SQL Server, MySQL, MongoDB, Cassandra, and more. Using VM images help you quickly deploy VMs with the configurations you need. A generalized image is a VM that's been reset to default settings, making it ready for reuse. It will reset the hostname, admin credentials, log files, and security identifiers. You can use the sysprep tool to generalize a Windows VM. After shutting down the VM, allocate it in Azure. This process ensures your image is clean and ready for deployment. Now, let's see how to create a managed image from a generalized virtual machine in Azure. First, select the VM you want to use as your image source. In the Azure portal, click Capture on the toolbar. Enter a name for your image and select the resource group. If you want to remove the source VM after creating the image, check the box to automatically delete it. Click Create to finish. You can also use the Azure CLI or PowerShell commands to create images programmatically. This makes it easy to reuse your VM configurations for future deployment. Later, you can create a new virtual machine from a managed image. Click Browse all public and private images, and then select My Items tab. Choose your newly created image. Azure Image Builder is a fully managed service that helps you create custom VM image. The process has three main parts. First, source. Choose your base image from the Azure Marketplace or your own managed images. Next, customizer. Apply your customizations, such as installing software or configuring settings. Last, distribute. Save the customized image as a VHD, managed image, or in the shared image gallery. This approach streamlines image creation and distribution across your organization. Azure Image Builder lets you add customizations to existing images. Here's what you can do. Create golden baseline images with your organization's security and configuration standards. Patch existing images to keep them up to date. Connect to existing virtual networks for further customization. Integrate with the Azure Shared Image Gallery for global distribution and version management. Migrate your existing image build pipelines to Azure. Create images in VHD format for Azure Stack support. This flexibility helps you maintain consistency and security across your deployments. To create a Windows VM using Azure Image Builder, first, register Azure Image Builder in your subscription. Next, create an image template that defines your customizations. Next, build the VM using PowerShell or Azure CLI. This process automates image creation and ensures your VMs are built into your specifications every time. Next, we'll look at how to automate the configuration on Windows Server IaaS virtual machines. Automation helps ensure consistency, saves time, and reduces errors in your deployments. Azure Automation is a cloud service for automating administrative tasks. Azure Automation can run long tasks on both Azure and on-prem servers. It integrates with log analytics for managing OS updates, server inventory, and configuration tracking. Its core components include credentials, modules, schedules, connections, and runbooks. It provides ready-to-use runbooks that are available out of the box. Automation helps you manage your environment efficiently and reliably. Azure Automation uses runbooks, which are collections of tasks that perform custom processes. Runbooks can be graphical or textual, using PowerShell or Python scripts. Assets are the building blocks for runbooks. You can test runbooks in the Azure portal before publishing them. This flexibility allows you to automate a wide range of administrative tasks. Desired state configuration, or DSC, is a key part of Azure Automation. To control a VM with DSC, onboard the VM with Azure Automation. DSC helps ensure your servers always meet your desired configuration. The Local Configuration Manager, LCM, is the engine that runs DSC scripts. You can deploy DSC configurations in push or pull mode. With DSC, you can define the desired state of an OS or application. You can use scripts or the Azure portal to create DSC configuration. To use DSC with Windows computers, you need Windows 8.1 or later, or Windows Server 2012 R2 or later. You also need Windows Remote Management and Network Access components. The Recommend feature lets you run scripts inside Azure virtual machines. It uses the VM agent to run PowerShell scripts within the VM. You can use it to manually correct configuration drift. You need the right permissions to run commands. Custom script extensions are used for post-deployment configuration and software installation. They help download and run scripts in Azure virtual machines. You can store scripts in Azure Blob Storage, GitHub, or internal file servers. Make sure your VM has internet connectivity if scripts are stored externally. Custom script extensions make it easy to automate complex configurations. Now, it's time for us to get practical experience in Lab 6. In Lab 6, you will deploy and configure Windows servers on Azure virtual machines. You will develop an automated deployment process for Azure virtual machines. You would like to address concerns about outdated operations, limited automation, and security by running Windows Server. In this lab, we will deploy and configure Windows Server on Azure VMs. Let's first log into the Azure portal. And from the Azure portal, we will do the configuration for the Azure virtual machines. And we will create a new one. So we will use the wizard to create the virtual machine. First, let's create a new resource group. Let's click OK. And then we use this virtual machine name. And for the availability options, as a demo purpose, we will choose no infrastructure redundancy required. But in production environment, you need to take advantage of the Azure availability zones. So let's scroll down a little bit. And we select the Windows Server 2022 Data Center as the image. We will use the default standard size for the virtual machine. And for the username, we will use student. And we will type in a very secure password. And then let's confirm the password we just typed in. For the inbound port rules, here we will select none. So we will do the configuration of network security group later on. Let's click Next. Let's close this. And for the disk selection, we will change from the default premium SSD to standard HDD. As we all know, this is for the demo purpose. Okay, and we'll keep the next configurations as the default. And for the networking part, here we will create a new virtual network. So first, let's name this virtual network as this. And we delete the default one, or maybe we can just modify it here. All right. And then we will add the subnet for this virtual network. We type in the IP address range for the subnet, and that's it. So we will create a virtual network with a single subnet in it. As mentioned earlier, we will skip network security group configuration. We will create a new one later on. For the public IP, we will select none. All right. Then we continue to the management part. We will use the default settings here. And let's click Next. In the Review and Create section, we will not create the virtual machine from this wizard. Instead, we will take advantage of the template generated during this virtual machine creation wizard, and we will do that from the command line interface. All set. So we will not click this button. Instead, we will click Download a template for automation. Let's click this one. As you can see, a template is generated for this Azure Virtual Machine setup. You can deploy it from the template, or you can download it to your local folder. So that's what we will do. Let's open the local folder. And then let's extract this zip file. So we first paste it into lab 6 files folder. And after that, we do the extraction. As we can see, there are 2 JSON formatted files within this folder. The first one is template, and the other one is parameters. So we can right-click the file and open with Visual Studio Code. So these are the template files that we will take advantage of when we create the Azure virtual machine. So you can use this method as an easy way for the automation. What we were going to do next is we will modify the file, right, to add additional resources into the Azure virtual machine, the Azure VM extension to be exact. So I have already copied the contents that we need to do for the modification in the Visual Studio Code. What we are going to do is we will add this section into our template. So we select out of the contents, do a copy, and we will paste it into the template JSON file. So let's scroll down a little bit and we find the section of resources. So this is where we need to insert the Azure VM extension part. All right. After this, we can save the modification that we have done. Okay. So the next step is to deploy the Azure virtual machines via the template. So let's just close this one. And this time, we will use ARM template to do the automation. So from the Azure portal, let's search template. And we select deploy a custom template. So from here, we can upload the templates on our local machine. So we click build your own template. And from here, we can load file. And then we browse the local folders for the template file. And we click open. All right, everything looks good. Let's click save. And then the next step is to do some parameter settings. So as you can see here, all of them have the value of now. So we need to add our actual parameters into the configuration. This looks better. Let's click Save. The final step for us is to choose a destination resource group for the deployment. So let's click the drop-down list. And we choose the resource group. For the admin password, we will type in the very secure admin password here. Let's click Review and Create. And finally, let's start the virtual machine creation. Looks like the deployment is complete. So this time, we can go to the resource group. And let's take a look at the newly created Azure virtual machine. We can click Settings, and let's take a look at the extensions. There we go. So the custom script extension is successfully installed from the templates. So you can use the templates as an automation way to do your Azure Virtual Machine setup. Next, let's switch to Microsoft Defender for Cloud. Now first, let's go to the environment settings to take a look at our current setting for this subscription. So there is one subscription associated with Microsoft Defender for Cloud. Let's look at what Microsoft Defender for Cloud plan is this Azure subscription using. Okay, as we can see, there is no plan associated with the subscription. What we can do is we can edit the setting. And for the demo purpose, we will enable all plans by clicking this button. But in the production environment, you can freely choose which feature or which plan you would like to enable. So for the demo purpose, we will just enable all plans for a 30-day free trial. So it will prompt you for choosing whether use Microsoft Defender for APIs. So here we'll just click cancel. After you are sure that the configuration is complete, you can click Save to save the current configuration. All right, and after we enabled the Microsoft Defender for Cloud plan, we can continue with enabling just-in-time access for the Azure virtual machine we just created. Okay, so the plan is enabled. Now we can continue with just-in-time access configuration. So first, let's switch to workload protections. For the just-in-time VM access, let's click this one. You will see that currently our Azure virtual machine is listed under unsupported. That is because when we were doing the setup, we didn't select any network security group for this Azure virtual machine. To successfully complete just-in-time access configuration, we need to create and associate a network security group for this Azure VM. We head to Network Security Group setting. And let's create a new one. We will give this network security group a name. And then we will continue the creation. Let's click Create. After this security group is created, we will add security rules into this network security group. Let's click Go to Resource. And here, we will add additional rules. We will add an inbound security rule for the Azure virtual machine. So as you can see, these are the default inbound security rules. We will add a security rule to allow incoming HTTP connection. So here we will select the HTTP service. And we will use 300 as the priority. And we change the role name to allow HTTP inbound. And click Add. During our creation of the Azure virtual machine, we didn't add any public IP address to the virtual machine. So to test our network security rule, we need to assign a new public IP to the virtual machine. So that's what we are going to do next. This is for our demo purpose. In production environment, we do recommend you folks to take advantage of the Azure virtual network services instead of exposing the Azure VM on the internet with a public IP address. So here we will just create a public IP v4 address. We will give it a name here. And we will review and create this public IP address. Here, we will disable the DDoS protection for the demo purpose. Okay, the validation is passed. Now we can create this public IP resource. Okay, so after the public IP is created, we can click Go to Resource, or we can go directly to the Azure virtual machine, and we will do the configuration from the network setting. Okay, we click Network Settings. And we will select the network interface card. So here we click Settings and Network Security Group. And we will associate the network security group with this network interface card. So we will select the NSD from the drop-down list and click Save. The next step is to associate the public IP address with it. So you can do IP configurations pretty easily from the network settings blade. So here, as you can see, it has an existing private IP address from the subnet. You can also associate public IP address right from the IP configuration setting. So here, we will select the public IP address from the drop-down list and click Save. Now we have the public IP address associated with this network interface card. So the very last step for us is to do the just-in-time access for this Azure virtual machine. Later on, we will use this public IP address to test our configuration. So we will first copy this public IP address for our later usage. As you can see, it is accessible from the internet. Now, let's configure just-in-time access for this Azure virtual machine. So first, let's click Connect. And from the Connect page, we can see that just-in-time policy is not configured for the remote desktop port of this Azure virtual machine. So you can click Configure for this port. It is very easy to enable just-in-time access for this Azure virtual machine. After the configuration is enabled, we can switch back to the Microsoft Defender for Cloud and to take a look. As we can see here, now the Azure virtual machine is listed under Configured tab. So from here, we can modify the just-in-time access. We can delete the existing settings and we can add new settings here. We can also configure the max request time. We can request access right from Microsoft Defender for Cloud, but you can also do that via the Azure Virtual Machine Connect page. So if we click Connect, you will see that now there is a link for request access. So you can do it right from the Azure Virtual Machine portal. So let's click Request Access. After you click this button, in the background, Microsoft Defender for Cloud will add a security rule in the Network Security group for this Azure virtual machine. So let's take a look. We will find the NIC, and let's click Network Security Group. So this is the network security group that we will take a look at. In our demo, there is only one network security group, so it is pretty easy to find it. let's click Inbound Security Rules. And as you can see, a new rule is added by Microsoft Defender for Cloud for the remote management port, and it has the highest priority. The action is Allow. This concludes our session. You've learned how to plan and deploy Windows Server virtual machines, customize virtual machine images, and automate the configuration of Windows Server virtual machines. There are many ways to continue your learning journey. We encourage you to watch other videos in this course, or search out your next favorite topic on Microsoft Learn at aka.ms/learn.